during the wake up. Okay, what happened when there are two forces acting at one object or one point? Okay, and how we calculate it. Okay, so now let's see how do we determine resultant force by using the triangle and parallelogram method. First, we start with the triangle one. Okay, let's say these are we choose the suitable scale, like 1 cm maybe equals to 10 Newton, or 1 cm equals to 1 Newton, accordingly. Okay, then we try to draw the first force, the first force and the second force. Then the resultant will be the point that connected together to form a triangle. So this is the resultant force. And then we just use the ruler to measure. Okay, to measure because we are drawing in scale. So we just measure how long the length of this, then multiply by the scale. How many Newton? Then we will get the actual Newton. Now for parallelogram, actually the method almost similar. It's just that we choose a suitable scale as well, and then we connected another way, the two forces. Then we resolve. Resolve means that like copy and paste. Okay, the first the first force to here, the force to here. Okay, then with this we connected 2 points from here to here. So then we measured the we measured the angle for the direction and the length of the force as the the actual force by multiplying with the length with the scale. Okay, 理解? Can you understand?
Scale is the region.
Yeah, normally because you are calculating the force in Newton, so normally it will be 1 cm or 1 mm equals to how many Newton? All right. Can I? Okay, Cindy.
Okay.
All right. Okay. Why you know her as well? Yeah. Oh, that's right. Okay, now from our Newton's second law of motion, okay, for those when you are interested in mechanical engineer, oil and gas, power engineering, power generation engineering, or if you love this if you love this we call this as civil construction. This will be the essence, like a Bible for you. And Mr. Newton's law, okay, there are lots of law from this Mr. Newton, the Mr. Apple. Most of his law are all converted into one syllabus book, 1,800 pages. All about Mr. Newton. Yeah, so it's like the Bible for the for these Christian, okay, or like the the Al Quran for this Muslim. You need to like put it on top of the shelf. Yeah. Give it a flower every day, something like that. Okay. So if you don't learn this, you may try to invent the invent the time travel machine, kill him before he started. Okay, kill him before the apple drop. Yes. Okay. So from the Newton's second law of motion, so from the relationship between the resultant force and this mass and acceleration will be F equals to ma. F is the force. We normally call it force. M is mass. A is acceleration. This is the standard formula for this one. And the resultant force and the relationship between the resultant force value with object motion. Let's see. So when F equals to 0, we say the object is stationary or move in constant velocity. Because constant velocity, acceleration is 0. Velocity is 0, acceleration is still 0. So with this, we say the force is in equilibrium. So that's why sometimes the question will give you the net force is 0. Net force is 0 means that total force F is equals to 0. Okay, it's like 5 Newton to the left and 5 Newton to the right. They cancel out each other. So this is equilibrium. Okay. When it's not equals to 0, so we say the object move with constant acceleration and the force is not in equilibrium. Can you understand? Okay, so jot this down. All right. Done, Okay. Cindy, done?
Yes. Yes, teacher.
Done, Okay. So let's continue. Okay, this is actually a short one because later we were going to go through like here. Don't worry. I won't ask you to copy the thing that I already asked you to copy. Unless I forget. If I forget, you need to let me know. All right. You see, old fella, short memory. All right. Too many things I need to remember. Okay. So now let's see the resultant force and the motion of lift. When you are in stationary, you see your weighting scale shows normal what you call normal weight. You won't change in your weight. Doesn't that normal weight means that your weight is there. When you stand on the weighing station, you still saw your weight. Doesn't say I said zero, so I stand on it, zero, no, you yourself has weight there. Okay, so let's say this is you. You are gonna have a W equals to mg because your weight there, but the resultant force is zero. So apparently your apparent weight, which is you remember on the third Newton's law, action and reaction, when we have an action going downward as weight, so we will have a normal force acting on opposite direction as R. So this R is actually your, what you call, your normal force. Okay, so now your R is equals to W, R equals to W is equals to mg, so R equals to mg. Now, when lift move upward, your resultant force will be R minus W equals to MA because there is a force moving upward. Total still zero. Total is F. So now your R minus W will equals to MA. So somehow your apparent weight R, the normal is equals to MA plus W because not only your weight going down, but there is a force pushing it upward, pulling it upward. So it's MA plus W. While when we change W equals to mg, you become R equals to MA plus mg. Now, when the what you call, so with this, the reading on weighing scale is higher or lower? Should be higher, because if we move upward, there is a pushing force pushing downward, makes you looks like heavier. So if now this is the way when you are wearing kulus, you want to cheat that you are a bit more weight, then you can stand when moving up. Now let's say when you are 100 kg, you have to show like you only have 50. So you weight it yourself when the lift move downward. Okay, jangan tekan salah. When you are in level 5, jangan tekan level 6 and then stand on the weight. You want to tipu, so we change it. B1. Why is that B1? Ask all body, don't tekan. Why is that B1? Because B1, the speed will go the fastest. Then you stand on it. So your resultant force will be W minus R. Why? Because your W is higher than R when moving downward. So that's why when the lift go down, you will feel like your head a bit light. When it's pulling outward, when the lift move outward, your head will looks heavy, right? That's the problem. Why your head looks heavy? Because your brain are covered with liquid. So the liquid being pulling down, your blood pulling down. So that's why you feel like, oh, you are lighted head. Okay, can you understand? So your apparent weight, which is R, will be equals to W minus MA or MG minus NA. Okay, so this is also why when you are having a what you call, when you have the what you call that when you go to Disneyland, Disneyland there's a we call this as a not auto free fall lift. Actually, he has a game called free fall lift. I don't know nowadays still got. I never go there before. I'm a poor guy. I never went there before. I saw my girlfriend show me before. My girlfriend has a very rich father. So when you go down, because why? During the free fall, we saw you go in. You need to sign a document so that the Disneyland will be out of any charges if you are having problems there. Because when during free fall, your blood will be pushing upward to your brain. So for those who have stroke or this hypertension, means high blood pressure, you cannot play this kind of thing because the blood suddenly go there, the blood pressure on your brain is very high. So for those who have stroke, when you go there, you stroke even more because the pressure very high. Okay, this is also, so that's why you see, remember the many years ago, I think, before this before this Genting Highland changed redecorate his outdoor and indoor theme park. There's there's like what we call the bubble jump machine. Right, you're going up to the top and then like drop down. That one also, they also shows that because when they free fall down, those with hypertension might cause stroke because the blood all go up due to inertia. So the blood pressure will go very high. That's why. Okay, can you understand? Because it drop very fast. Unlike lift, lift is a totally different thing because lift move very slow. If lift move free fall, nobody dare to use lift anymore. Like you go to what you call the twin tower. Twin tower, you can actually buy a ticket and to go to that's one, right? Try to imagine 100 something, and then he go like the full speed. Oh, congratulations. See, okay, can understand? All right, so jot this down. Okay, you can draw if you want, but don't draw like detail Use the what you call orang kayu mancis okay. I don't know the name I think there's a game the slash around one using the people orang mancis like that. Okay.
Teacher, I'm done.
You're done.
Yeah.
Okay. Don't worry. Of course, she's doing it when I was explaining. No, but if she done it within 1 minute, the hand is like.
How would be slow poke then?
Uh-huh.
How would be slow poke then?
How slow poke then?
但是老师，我有听你在解释，我一
那我
点
知道我们是在讲笑话，不要在意。
没有，我是在跟你
关心
讲话。
真心来开玩笑，因为这种科目太闷了。如果我没有一直开玩笑把你们引回进来你们很容易什么？很容易飘走那个思绪。
嗯。
Done. Done, huh? All right, now let's see when we apply the same theory in this, we call the pulley. Okay, so now let's see. When a force F, we use it to pull a load over a smooth pulley. What's called smooth? Smooth means that no resistance. This is not the point blank. This is actually no. Okay, I'm afraid that because sometimes I do the note, I can also put this one. This is called no resistance. Okay, so the tension T is equals to the pulling force. So means that F is equals to T lah. So the load is stationary. When the load is stationary or move with constant velocity, so your acceleration A is 0. So it's like when it's like this, the acceleration A is 0. When A is 0, so T minus mg equals to ma. Since A is 0, so T minus mg. And T minus mg, okay, this moves here, so the tension is equals to mg. So since F equals to T, so F equals to mg or equals to weight. Understand? Because it didn't move, stationary, means that the left side and the right side is the same, correct? And then the upward and downward is the same, is cancelling each other, right? So of course, cancelling each other, T must be equal to mg because the only force making downward, going downward is W, because F is 0. Correct? So somehow the total force is equal to mg. Okay, or equals to T lah. You understand? All right, jot this down. You don't need to draw this out, of course. This man no need. You just need to draw the pulley with the load only. Pulley, like the one you saw when you want to drag something up. So means that you are a kid, very bahagia one. Never, no need to do hard work.
老师，那个 diagram 要讲话哦。
你只需要画一个这个圆的在这边，这个圆的，然后你画一个这样2条线哦，然后这条线这边你绑一个四方形一条。
OK。
总之你就是把那个人拿掉一条。不过那种箭头你不要漏掉了。
OK。 老师好了，
好了，OK。Done, huh? Okay, now let's see the second one. When we try to pull it up, so the load is pulled upward with acceleration A. So now, okay, now the tension is more than mg because before this the is stationary man. Now is moving upward. So now the tension is more than the weight because you need to drop the force must be more than weight so that the load will move up, correct? So applying the force F equals to ma. So F is T minus mg equals to ma. Move it here, T is equals to ma plus mg. So since your F is equals to T, so F is equals to mg plus ma. We are actually he can this force and this force is different. This is resultant force. This is just the force. You can understand that? Looks confusing, right? And it's actually confusing because this is actually the force that applied by this guy. This is the resultant force. Don't ask me. With my time, we are using F resultant. Nowadays, they want to save the space to save cost. So now they use F only. Hail Ministry of Education. Okay, so jot this down. Okay, done, huh? Voilà.
好了，
好了。
好了。
Okay, wait, give me a second. 给我一点时间。Wait, give me some second.
OK。
All right, now let's continue. Okay, now let's see. When we use two weight on both sides, one weight both sides. So when two load hung using the same string over a smoothed pulley, so the heavier load will accelerate downward, while the lighter load will accelerate upward, with the same magnitude, while the string tension is constant because you see, the tension will move from here, exerted from here to here, here to here. So the only different thing is direction, but the magnitude is the same. Okay, so now when M2 is bigger than M1, so F equals to MA, so it's like weight 2 minus weight 1 equals to M1 plus M2 A, because in short, after some time, when this one is heavier, this one is lighter, this will move upward and this one move downward, right? The acceleration of moving upward and downward is the same. Okay, can so this is why. So that's why the formula will be W, while weight 2 minus 1 equals to M1 plus M2, but we are using sharing the same A because they are actually in the end, it's like when it's going up like this, right? We're going up, and in the end, both will go downward. Correct? Right? So the initial, the M1. So after that, you will move here and here. So both move in the same acceleration. So the force will be this one and this one, because it's like both the load is on the same side, right? When you get pull, of course it will pull over, right? It's on the same string. Same string is like they are pulling over on the same side. So when on the same side, this you imagine that when they're on the same, it's like on the same side. So the total mass will be mass 1 plus mass 2. Can understand? OK can understand 可以理解Cindy，因为它移到后面的时候你看这样，你这样往下拉啦，你就可以把这个东西 exert 到这个地方，所以他们两个就好像是在一起往下。所以我这一边为什么是用 M1 加 M2？因为他们是一起往下的。
明白。
可以理解？
可以。
对啊 ，All right, got this down.
老师好啊，
Done, sir.
Done, huh? Okay.
Wait. Done.
Done. He don't want to. She don't want to give you chance to call her slow punk. Okay. Now, you see, this is the what? This is the what you call the how we should wait. It's like it seems like I want you to try this one. Should I? Let me check. Yeah, no need. Very easy. It looks like very easy. No need. Okay, now let's see. When for a 20 Newton and 10 Newton move on the same side, so the resultant force will be 20 plus 10, which is 30 Newton, and the direction of motion will be on right. Now for this one is higher, 20 minus 10. Okay, because actually the calculation is 20 plus negative 10. Why negative 10? Because the direction is different. So it becomes 10 Newton to the right. 10, 10. So they will cancel out each other, which is 0. The resultant force was 0. So it stays stationary. Now, for this one, normally on the right is positive. So 10 plus negative 18. So you get negative 8 Newton. Negative means go to the left. Now, for this one, 15 upward, 4 downward. 15 plus negative 4, which is 11 Newton. Remember, when he didn't give you the reference direction, okay, on default, right-hand side and go upward is positive. Okay, left and downward will be negative. So this one move forward. Now, for this one, we have a 12 Newton here, 5 Newton here. So the resultant force will be this one. So it's like F equals to, this is a what you call, I resolve this one to here, right? So it become 12, 5, a triangle, something like that. You see? So we can use theorem Pythagoras. So 12 square plus 5 square. So you will get 13 Newton. So you want to get this angle. So the angle here is you can use tangent tangent theta equals to F1 over F2. Okay. So this one moves here, shift tangent theta equals to shift tangent 5 over 12, which is 22.6 degree from F2. You must mention from where. Okay, this is important. Okay, now next for this one, pretty easy. Okay, this one lower, this one higher. So it's 450 plus negative 600, which is negative 150 going downward. This one, 1,000, 1,000, cancel out each other. So 0 Newton means stationary. Okay, pretty easy. The hard one will be this one. Normally, this is the one that you always face. Okay, be careful. Now, this one is how we should use the triangle method for the calculation. You remember just now I asked you how to draw it, to scale. Okay, now you see, now you have 100 Newton and 1200 Newton. In the middle is 60 degree. So by using the triangle method, this one here, let's say 1 cm equals to 50 Newton. So 100 Newton will be 2 cm. 200 Newton will be 4 cm. So 60 degree. Okay, then you sumbong it. So it will become 5.3 cm. So 5.3 cm is times 50 Newton per cm. So you get 265 Newton as the resultant force. So the direction will be this one, 41 degree from F1. You understand? Now, when you are using the parallelogram method, so this one is 2 cm, this one is 4 cm. So then you resolve this one to here, resolve this one to here. So it becomes a parallelogram. Then in the middle, point to point, we draw it up. So you will find out that this is 41 degree. All right, this one is 41 degree from force 1 here. And the length of this is 5.3 cm, which is 265 Newton. You understand?
Then how do the 41
Here, you measure how you measure using your protractor. Using protractor. Okay? Use protractor. Now, so let's see how we solve the problem involved resultant force, mass, acceleration of object. So first we need to calculate the acceleration, then we state the direction of motion. So this is the questions. Now first, F equals to ma. So your F is 8 plus 4 minus 2 equals to 3a. So from here you will get a is equals to 3.33 meter per second. Okay, because you move 3 here. So 8 plus 4, 12 minus 2, 10. 10 over 3. So you get 3.33. So move to the right because right hand side is more force, has higher force. Now, same goes here. 8 cancel each other, but you cannot say cancel out, cannot. You need to mention. So it's 8 plus negative 8 equals to 3a cosine. So a equals to cosine. When a equals to cosine means the direction is no moving, or we call stationary. Now, for this one, okay, we use 8 plus negative 5. So 8 minus 5 equals to 3a. So a will be equals to 1 meter per second going upward. Okay. Now for number 4, this one, by using the formula F equals to ma. So F is 50 minus 20. You see, because going down, both going down, correct? But actually, when going down, this one going down, when I drag to pull it into straight line, 50 go here, 20 go here, correct? It's not same direction. Can you understand 可以理解Cindy 为什么我明明两个向下，为什么我剪掉因为我这个伸直，它就变成一个左一个右Okay? Understand So in order to imagine when you face this kind of questions, you need to imagine that if I pull it into straight line, then actually both string represent different direction. Okay, so we use total direction is 50 minus 20. Okay, so the mass is 5 plus 2. Okay, so A will be 4.29 because remember, resultant force only moving on one direction. That's why we consider the two loads are moving together. Okay, so it's downward to the direction of 50 Newton. Okay, All right, now a car with an 880 kg moving on the road with constant velocity. Constant velocity means that acceleration equals to 0. Constant velocity is 0 acceleration. So the force exerted by the engine is 1600 Newton. So what is the frictional force? So we know that total force is normally the force exerted by the engine, right? Because the car moves with engine's power. So the force exerted by the engine minus the frictional force between the tire and the road. So 1600 minus R equals to 880 MA, 880 times 0 because constant velocity. A is 0. So from here, we move R here. Negative R become positive R. So R is equal to 1600 Newton. Okay. Now, calculate the acceleration of the car. If now the force exerted by the engine is 5,000. So 5,000, so it means that 5,000 F equals to MA. We know that R now the frictional force is 1600 Newton. So will it change? It won't change. Your frictional force won't like, okay, now I'm driving pickup. Like the, what I call that? The Honda, no, the Toyota, what I call? Hilux. So suddenly, the road become very, very sticky. So the resistance become very high. When you drove BMW, the what I call the car, the road smooth like hell. Like you can like straight away blown up your petrol, your speed from the top of the Genting Highland to the bottom. Don't do what my boss do. When he go down, going very fast, with his GTR, then there's a roundabout. The moment the roundabout there, he's losing the control. He just pulling up the steering, and his car it's like dragging like one round. Or those people at the midnight, you see a lot of people those Olympic, they like Olympic there, all like dragging down the windows. Who are your power man? But he tell me that I was scared like hell because the car is out of control. See, so there's two messages comes out from here. First, don't drive too fast when you are in Genting's highway. Second, GTR is a good car. See, not even the car is now losing control, still able to control by steering. So it's a pretty safe car to have. Nissan has a good handling. Okay. If Porsche, sorry, you are Porsche crash already. Porsche's handling is like hell. I drove Porsche I drove once. Not mine, sorry. My professors. BMW, the 7 Series, okay if you want to have a chill and you are not the one who drive, the passenger seat, yes, very comfortable. But for the one who drive it, sorry, I don't think you have a very good moment because I am the driver. My professor not going to drive. For sure, she is not going to drive. I will be only the driver. See, you see, he is buying the car through the Europe country. So they're using miles, I don't know. I drove like hell, 200. I said, no, 120 miles per hour. I was like, why you drive so fast? My professor asked me, 120 ma, okay a little bit over the 110 ma. This is fucking miles, man. I was like, oh shit. So we get 2 summons, but 2 summons are waived. Why? Professors he said, I am rushing for a meeting with the government, blah blah blah, on Sunday midnight. Who the hell is going to have a meeting on midnight? But the government believes it. Okay, it's waived. See, professors is a really good job. Okay, so in short, 5,000 Newton, you need to minus the 1,600 Newton. So equals to 880 A. So the acceleration now will be 3.86 meter per second square. Remember, There are several things. If there is a frictional force involved, normally the surface friction are considered the same. Normally, as long as he's not playing around with the questions. SPM pretty easy. Normally it's the same. But if you ask me, is the friction same? No. Why? Every car has different load. The mass is different. Can you assume that, like the what you call it, McLaren, who is made up of a whole body of carbon fiber, compared to like the what you call the Mr. Bean car, which is made out of steel. For sure, the steel car will be heavier, right? So which one has a more higher friction? Yes, no, the steel car has higher because heavier, load going down, see, so this is why, like I said, when you go Form 6, why Form 6 they always say, oh, you're so hard, everything is different for sure, because before this, you guys are always in a very comfortable zone. We call ideal condition. No friction. No, that's impossible. How on earth there's no friction? If no friction, how you gonna stop your car? Right? Tire no friction, you have the brake useless because no friction is like pushing it when you try to brake. Yes, your tire is stopped, but the car is still moving. See, but this is why I always say Form 5, Form 4 SPM, at least 70% formula are wrong or unusable in Form 6. This makes Form 6 tough because you know they drag the graph, now it's no longer hide anymore. They didn't hide anymore. We even know the numbers nowadays. 12 marks for getting a pass. No, 8 marks for getting a pass for admits last SPM. Congratulations, 8 marks. So try to imagine if you fail it. How on earth you're gonna fail it because you got a D for 8? 8 marks is enough for you to get a D and you get failed. Try to imagine how on fucking earth you get failed. You know how bad it is on the trial. My class, okay, all pass are C at least, and there's 2 of them B on trial. 70% fail. And then suddenly, all of a sudden during SPM, within 1 month, all people get very good result. Wow, it's like magic, you know? So this is like what I say. Don't believe. I mean, don't believe what our government show us. Like that. Okay. All right. Now let us see some. I'm going to give you some assignment, and don't let your beloved teacher know that I explain this type of thing to you. Later on, he will say again. He or she, okay, will keep saying again. This guy don't know physics one lah. I still remember. And that day I just saw my uncle again. He talked about this again. I said, "Aiyah, that guy don't know physics one lah. My PhD go for nothing lah." He said, your canteen tauke become like nothing to say because I'm very angry, still very angry. Okay, done. Can see clear. Okay, do this. Okay, please do this. Meanwhile, give me like 10 to 15 minutes. I want to grab my lunch or dinner. I don't know the name. Combined. No, lunch is only for lunch. No, you see, when we call yes, of course. Go ahead. The breakfast is for like. Is it the I use the one because I think the top one is the hard paper. Okay. It's like what you call? Because you see, you should go lunch first time because like what you call that? Breakfast plus lunch is brunch, right? Because breakfast comes first, right? Now lunch and dinner, lunch comes first, right? So it's very hard to read. But my lunch, this is what my girlfriend told me. Lunch, Okay, I will be off a while. So Cindy, if anything, you drop message by typing because I'm not around.
Okay. Okay.
Yes. Ya, terima kasih kalau kamu ada bersih. Semua sama kamu. And then look is going to be part of your group. Really, like, I'm going to be part of like, I'm not going to be part of my group. Me, really, that is the thing. It's like, no. Please, what are you doing?
Okay. Yes. Oh, let me see. Done, huh? Okay. Done, huh? All done, huh? Good. So let's continue. So first thing first, so the diagram shows a ship which is pulled by two boats with a force of 3,500 Newton and 2,400 Newton. So what's the magnitude and direction of the resultant force given by the boat? So let's dissolve here to here. So this is 3,500, this is 2,004. So 90 degree. So in order to get the force, so it's a right triangle 90 degree. So we use theorem Pythagoras. Okay, 3,500 square plus 2,400 square and set it. So you get 4243.82 Newton. Now for the angle, theta is equal to shift tangent 2004 divided by 3005, which is 34.44 degree from F1. Correct? You need to write from F1.
Yeah.
Now, the diagram shows a student standing on a weighing scale in a lift to study the effect of the movement of a lift on the reading of the weighing scale. So what is the weight of the student in unit of Newton if his mass is 60 kg? Mass is 60. So he said G is 10. So 60 times 10 mg equals to 600 Newton. Now, next. Complete the table below by calculating the apparent weight and the reading of the weighing scale in each type of motion. Now, when at rest, R is equal to W, so R is 600 Newton. So the weighing scale reading will be 60. When you're moving up with acceleration of 2 meters per second, so moving up, R minus W equals to MA, right? So MA, so your R will be equals to 122 times 60, 120 minus W become 100 plus 600 because the weight is mg minus 600, right? So equals to 720 Newton. 720 Newton. So the mass will be 720 over by divided by 10. So you get 72 kg. And when you're moving up with uniform velocity, so uniform acceleration cosine. So R is equal to W, 600 Newton. So the mass is 60 kg. When you're moving now with uniform velocity, R is equal to W as well, 600 Newton, and M is equal to 60 kg. Because no matter up and down, uniform velocity means cosine. Now, when you're moving down with acceleration, 2 meters per second. So now, just now, when you're moving up with acceleration is R minus W. Moving down is W minus R equals to 60 times 2. So move here, this move here. So it's 600 minus 120, which is 480 Newton. So M equals to 48 kg. Can I? Correct?
No.
No. No, do the correction, jot down the correction, remember? So compare the 等一下，那个who is that？Cindy 做对吗？
老师，我跟你讲，我 miss 掉 B 跟 C 啊，就是我做2A 罢了。
哦，OK，不要紧。那么你现在看得懂啊？这边怎样做？
看得懂。
看得懂啊？它这个 formula 是刚才你抄的那个楼电梯的那一个的 formula 的。
对。
OK 啊，好，你把它记录下来好不好？
嗯。
Okay, done. So let me go. Let us compare the normal reaction with the weight of student when the lift move up with acceleration, and explain why. Because when it move up, right? So the normal reaction is greater because the resultant force is act on upward. So the normal reaction is equals to weight of student plus the net force, which is mg plus ma. So that's why the what you call the weight will go up. The weight will get higher. Okay, this is how the normal force are. Now, what is observed on the reading of weighting scale when the lift moves down with acceleration? Move down, the weighting scale reading is decreased. Why? Because the normal reaction now is smaller than the weight of the student. Okay? Because weight is always the same, right? So the only thing that can affect the reading is on the R side. Okay, the R side, because now it no longer kosong, right? It's no longer, when it's moving, it's no longer equilibrium. So when R is greater than W, so it means that the total weight is heavier. When R is less than W, so the total weight is lower. So that's why when you go down, lift go down, your weighting scale reading is smaller. Can you understand? 可以啊 ，Cindy 听得明白？
听得明白。
Okay, now, so let's see. Diagram shows a toy car, okay, with mass 2.5 kg pulled by 0.5 kg load over a smooth pulley. Well, looks like a DIY product. The product sell in DIY. Okay, Mr. DIY. So if the friction between the tire and surface is 2 Newton, now is this ideal condition? No longer ideal condition. This is not a smooth surface. So he wants you to calculate the acceleration of a toy car. So we know that F equals to ma. He said the F is 0.5 kg load. This is the F dragging down. So use 0.5 times 9.81. Then we need to minus the 2 Newton as well, because there's a friction, and the friction is on different direction. This one move down, this one move up, like that, correct? So you need to minus 2 equals to 0.5 plus 2.5. Okay, multiply by A. So shift everything left. A is 0.97 meter per second square. Can you understand? Okay. Now, for the tension of the string. So the tension of the string, you see, there's we call just now 2 Newton. This is the tension. And this one, that tension is you need to minus it because this one will actually increase the load back. So T you need to minus with 2 equals to 2.5 here because it's what you're talking about here. T is here. Correct? So these two are different direction. Total force P minus 2 equals to 2.5 times 0.97, the acceleration. So you get T equals to 4.4 Newton. Or from here, this is T, right? So 0.5 times 9.87. This is F. So minus T, correct? Equals to 0.5 times 0.97, the total FA. So with this, you get T equals to 4.4 Newton as well. You understand? Huh? So there are two situations that how you calculate this one, either on this side or this side. Okay? Boleh ya? Okay? Sure? Any questions? No? I know. I already know that you don't have questions. Because you are rushing home. Right? Like maybe Peter Hannah is rushing home to get the phone and have a call. With who, I don't know. Hard to say, ma. Maybe boy, but hard to say. Maybe girl as well. He has a special favorite. It's hard to say. Well, I'm very open, although I didn't encourage unnatural relationship, but still, okay, I'm open. Okay. Cindy might be hard a bit because Cindy she's in home. I think. So when the father is at home, you see, we have a pronounce Chinese. We say the daughter is like the ex-girlfriend of father, or the girlfriend of the father, or last life. So try to imagine when the father saw the daughter's boyfriend. Holy shit! It's like the sworn enemy. You know. So it's pretty hard as well. And so maybe Cindy will, if let's say she had a her or he, hopefully it's a he lah. So she might call or text it inside the blanket lah, before sleeping. Okay, just for fun, just for joking.
Teacher, I don't have Pakitana.
You don't have. It's hard to say, ma. You say you don't have. You know, my friend always told me that, "Yo, Ali, I didn't do my study, but she get 100 marks for that." See. So like Surendran, looks like a playboy. So maybe lots of calls she need to make. Okay. So I think I will stop here for today. So see you.